All right, guys, today we're going to look at quadratic modeling. In our last lesson, we looked at linear modeling, and today we're going to look at parabolas that either go up or go down. All right, this toolkit modeling here was for some examples just to talk about whether parabolas open up or down, but those, throwing a ball from one person to another, making widgets in a factory, a satellite dish facing directly upward, and then these are the variables. These are all just examples of parabolic modeling. So the first thing we want to do is find a quadratic model that goes through these points. And since I don't have an online graphing calculator that works on the iPad Pro right now, I found a video using similar points. So we're just going to look at that real quick and let that play. Hopefully.
1, 4, 215, and 332. So let's go over here to the TI-84. What we're going to want to do is we're going to want to go to Stat, right here, S-T-A-T. Let's go ahead and press that button. You want Edit. I'm just going to be pressing Enter for Edit. And then List 1 and List 2. Now in List 1, you want to enter the X coordinates of the points. So I'm going to enter 1, 2, and 3, and I'm just pressing the Enter key. And then if you go over to List 2, I'm going to enter the corresponding Y coordinates. So that's 4, 15, and 32. Okay, so you can see the points there, 1, 4, 2, 15, 3, 32. Then what you want to do is you want to go back into Stat, okay, for statistics. You want to arrow over to Calculate, and you want to head down to Quadratic Regression number 5. I'm pressing Enter, and then what you want to do is you want to arrow down, List 1, List 2, all the way to Calculate, and then press Enter one more time. And you can see what it's doing is it's giving you the A value here, which is 3, the B value, which is 2, and the C value is -1. You just have to substitute those in for A, B, and C, and you've got the equation of your quadratic right here. So if I was to write it, it comes out to y equals 3x squared plus 2x minus 1, and that's your equation. So if you enjoyed this video, take a look at some more of the TI-83 and TI-84 videos that I did on Mario's Math Tutoring YouTube channel. Subscribe.
All right. Anyway, that's how you're going to put that in your calculator with these points. Again, he had similar points, but you're going to go ahead and put that in your calculator. You're going to end up with A equaling 2, B equaling 3, and C equaling 4 for an equation that is 2x squared plus 3x plus 4. All right? Literally, that's all you're doing for this equation, for example 1. Other things to remember, and we've talked about this a little bit over, this unit. The graph of a quadratic model is called a parabola. Several key features. We have y-intercepts. Sometimes we have two x-intercepts. We have a vertex. The axis of symmetry is the equation of the line that divides the parabola in half as a mirror image. The equation of the axis of symmetry is x equals -b over 2a. It is also the x value of the vertex. All right, as you can see that here. The y-intercept is the c value in this equation, and the x-intercept is the roots, meaning if you factored your quadratic equation, you would get what you needed. You'd get your x-intercepts. And the vertex is halfway between the x-intercepts. So we have a quadratic model has the following properties. The axis of symmetry of y equals f of x is at x equals 4. All right, so we know we're going to take step 1 and we're going to say that -b over 2a is equal to 4. Okay, so that is one piece of information we know from this guy right here. Step 2, the y-intercept is 12, so we know c equals 12. We also know that the curve passes through the point 1, 5. So step 3 basically says when x equals 1, y equals 5, and if we plug that into ax squared plus bx plus c equals y, we would get a times 1 squared plus b times 1 plus c, which is 12, equals 5. All right, so that's a plus b equals -7. Up here, if we look at this equation, we get b equals -8a. All right, and we could look at that as 8a plus b equals 0. So we have a system of equations right here. All right, so we're going to take that system of equations, 8a plus b equals 0, and a plus b equals -7, and you can either use your graphing calculator to enter that like we did with the matrices, matrix A, and do the R reference of matrix A to get your values. And if you do that, you will end up with 1 and -8. You could also just look at this and realize quickly, if I multiply this whole thing by a negative, I end up with 7a equals 7, so a equals 1. Plugging that back in, b equals -8. So whatever is easiest for you, but that gives us all our variables. So a is 1, so we have 1x squared minus 8x plus 12, and that gives us the equation of the parabola that satisfies those requirements. Find the roots. In order to find the roots, we would just say what multiplies to 12 and adds to -8, and that would be -6 and -2. Set each one equal to 0, so x equals 6 and x equals 2. Those are my x-intercepts or roots. And the last part of this question says find the minimum value the model takes. Well, that just means we know that the minimum will be at the vertex, and we know the x value of the vertex is at 4. So we just plug in 4. So 4 squared minus 8 times 4 plus 12, and that equals -4. All right, so that gives you the minimum value. So when x equals 4, y is -4. So that is an ordered pair. All right. So just using information to be able to find an equation of a parabola, or being able to enter that information into your graphing calculator to find the equation of a parabola. And again, the exercises are on this page. Actually, I guess they're just on that page. And that's all we got for the day. So hopefully these little mini lessons are helping and just keeping your workload to a minimum, but getting the important key ideas that you need for all these important pieces of material.